So let's start the lecture number 2 of this course. Now in the previous lecture we discussed regarding importance of materials in engineering. We have also seen, or we have also discussed, what is the difference between material science and engineering. Lastly, we discussed about the classification of material, and we noted that we can classify the material in 4 categories: metal, ceramics, polymers, and composites. Now let's start with the topic crystal structures. And first of all, let's try to understand what is crystalline material and what is non-crystalline material. Now to understand this crystalline and non-crystalline, let us first understand some important terms. And the first term we are going to discuss is space lattice. If I consider arrangement of points in a 2D space, let's say I am considering this arrangement of points in a 2D space. Now for this arrangement, if I take into consideration this point, let's say, and then if I see how the neighbor points are arranged. So if we consider this atom, we can see that we have one atom at the top, one at the bottom, one on the left, and one on the right. Now for this arrangement, if I consider any other point, I will see that the neighboring arrangement of the points will be similar to this. For example, now if I consider this point, again I have one on the right, one on the left, one on the top, one at the bottom. We can understand this by drawing these vectors. Let's say I am drawing this and this, and let's say this is a unit distance. This distance is unit, and this is also unit distance. Now considering this point, if I look at the neighboring arrangement, then I have one point at unit distance on the right side, one point at the unit distance at the top, then I have one point at root 2 distance over here, and I have one point at root 5 distance somewhere over here. If I consider any other point over here, let's say I am considering this point, then I will see that I have similar kind of neighbor arrangement. I have one point at a unit distance, one point at a unit distance, one point at root 2, and one point at root 5. So this is similar. Now I have considered only the arrangement of points up to some limit. If we imagine that there are some more points, if we extend this point arrangement, and if we consider some more points, then we will see that if I consider any other point, I will find the neighboring arrangement same. So this is called a space lattice. And we can say that here the points are arranged in a repetitive manner. And these points are called lattice points. Alright. So this is the definition of space lattice. Now I can also consider 3D space lattice. Here I have considered 2D. Instead of that, I can also consider 3D space lattice. So for example, if I draw some arrangement like this, okay, so if I draw this type of arrangement, I can say this is a 3D space lattice, because here also you will see that the points are arranged in repetitive manner. If you consider any point on this arrangement, it will have similar type of neighboring arrangement. So this is the example of 3D space lattice. Now instead of this, instead of the arrangement of so this is the example of 3D space lattice. Now instead of this arrangement of points, if we consider that we have arrangement of atoms. Okay, let's say I have one 2D space lattice. These all are the lattice points. And now I am considering that there are atoms arranged at each lattice point. These are the atoms. So now in this case we can see that the atoms are arranged in repetitive manner. If the atoms are arranged in such a way, in repetitive manner, we will say that that is a crystalline arrangement of atoms. And such material will be called as crystalline material. Similarly, if we consider 3D space lattice, and here now if we consider that we have atoms situated at each and every lattice point, then we can say this is a 3D crystal structure, 3D crystal system. Okay, so this is also crystalline arrangement, and such material is called crystalline material. So that gives us the definition of crystalline material. What is it? Crystalline material is a material in which atoms are arranged in pattern, or we can say they have repetitive arrangement. This type of materials are called crystalline material. If the atoms are arranged randomly, they are not following any pattern, then it will be called as non-crystalline material. Okay, so this is the difference between crystalline and non-crystalline material. Now, because of this difference in atomic arrangement, crystalline and non-crystalline materials have different properties. For example, in case of crystalline material, we can define properties along any particular direction, which is not possible in case of non-crystalline material. Okay, so secondly, we can say the crystalline materials have sharp melting point, whereas in case of non-crystalline material, we find that it has range of melting point. Okay, so there are such differences, and those differences are because of the atomic arrangement only. Okay, now next let's see what is basis in case of this crystal arrangement. What is basis? So if we look at this crystal arrangement, we can see that we have one atom arranged at each lattice point. Okay, so we have one arrangement of points which is repetitive, and at each point we have one particular atom arranged, right? And these atoms are of the same type, so we will say that this is a basis for this system, for this structure, crystal structure. This is a basis. It is not always necessary that we have only one atom as a basis. For example, if we have this type of arrangement, and together with this we have one more atom situated this way. So here we cannot say that this is a basis. We have to say that this is basis. These two atoms combinedly form basis. Alright. Now what are the examples of crystalline and non-crystalline material? So in case of crystalline material, we have iron. or we have copper, we have aluminum. All these are examples of crystalline material. For example, iron have BCC structure, copper and aluminum have FCC structure. And what is the example of non-crystalline material? The example of non-crystalline material is glass. And we know that glass has range of melting point. It will not show you one melting point, sharp melting point. Okay, that is because of non-crystalline arrangement. If we look at the atomic arrangement in case of non-crystalline, it will be random like this. If we want to show it, we can show it by random atomic arrangement. It will not form any pattern like this. Right? Now let's define the next term related to the crystal structure, and that is unit cell. Again, let's take the example of this crystalline arrangement. These are the atoms. Now the definition of the unit cell says, unit cell is a cell. Okay, let's define. It is smallest possible cell which can be identified in crystalline arrangement and which forms repetitiveness. Okay, so this is the definition of unit cell. For example, if we consider this crystalline arrangement, we can identify this as a unit cell, as this is a 2D arrangement. We can identify this square as a unit cell. Also, we can identify this square as a unit cell. Right? Now, in case of 3D arrangement, if we look at the 3D arrangement, let's take this example. For this, if you want to define unit cell, we can define it by a cube. So here we can consider this cube, which I have drawn separately over here, and we have atoms arranged at each corner. So this can be considered as a unit cell. Right? Now once again I am repeating the definition of unit cell. It is the smallest possible cell which can be identified in crystalline arrangement and which forms repetitiveness. Alright. Now what are the different types of crystal structures which we are going to study? So in this course we are going to study 3 structures in detail. First one is BCC, which is body centered cubic. Second is FCC, which is face centered cubic, and third one is HCP, which is hexagonal close packed structure. Now the names to this crystal systems are given on the basis of the unit cell which they possess. So let's try to represent these three unit cells. If we want to represent a BCC unit cell, we can represent it by drawing a cube and we have atoms arranged at each corner, as well as we have one atom arranged at the body center. Okay, this is at the body center. This is how body centered cubic is represented. If you want to represent FCC, we can represent it by drawing a cube we have atoms at each corner, right? Also we have atoms at face center. So let's say if I am considering top face, then this is the center of the top face, right face center, left face center, front face center, back face center, bottom face center. This is how FCC is represented. And last one is hexagonal close packed structure. So here we have hexagonal unit cell rather than cubic unit cell. So this can be represented by a hexagonal prism, we have atoms at each corner, top face and bottom face. Also we have atom at the top face center, one atom at the bottom face center, and we have three whole atoms inside the cell. Okay, so this is how HCP is represented. So mainly in this course we will discuss these three crystal structures in detail. So let's end this lecture over here, and in the next lecture we will continue discussing some important terms related to crystal structures.